Hi, good morning, ladies and gentlemen. This is section 7.4 of Mrs. Quinn's geometry class. And this is our last section for the semester. We'll jump right in. Given the NK bisects angle JNM, so if NK bisects this angle right here, do you agree I can draw these congruency markings on either side? My JNM is bisected, so I know that these two are congruent to each other. And then my NM is congruent to NK, so I can say, hey, this side is congruent to this side. And I also know that NL is congruent to NJ. So NL from here to here, is congruent to NJ right here. So notice that I have side length, angle, side length, and over here I have, in the same order, side length, angle, side length. So let's start with our givens. NK bisects angle JNM. I know NM is congruent to NK, and NL is congruent to NJ. All of those are my givens. Now I could say, hey, these two angles are congruent to each other, just like I did on my figure. So I'm going to say the measure of angle JNK equals the measure of angle MNK. And I could say my two triangles are congruent. That's all that I need to do. Because now I can say, hey, triangle JNK is congruent to triangle LNM because of what theorem? Hopefully you're thinking side angle side theorem. Perfect. All right, look at our overlapping triangles. Sometimes now, instead of separating our triangles out, we're going to look at our triangles overlapping each other or interposed on each other. So let's look at this one right here. If I have AC is congruent to AB, and AD from here to here is congruent to AE from here to here, it might help us to redraw this. If you see this triangle right here as one, you can kind of see it like this. This segment is congruent to this segment. And over here, if I redraw this one, I would get this shape, this segment, and this segment. And now it's a little bit easier for me to look at, right? And finally, I'm given AD. Oh, I already wrote that in. AD is equal to AE. So now I'm given those pieces. Now, as far as my figure, what does my figure show me that these two triangles share? Do they share a side length? Do they share an angle? Hopefully you'll agree with me that they share this angle right here, right? Don't they both have angle A right here? Indeed they do. So now let's go ahead and start our proof. I'm going to start with AC equals AB. Here I'm talking about their length, so I don't need my segment symbol. And AD equals AE. So I'm going to then, given. Now I'm going to say, hey, the measure of angle A equals the measure of angle A. Or I could have said angle A is congruent to angle A because of the angle congruence postulate or the angle congruence theorem. I know that both of those are imply each other. So if I'm saying the measure of angle A equals the measure of angle A because of the reflexive property, now I can go ahead and say my two triangles are congruent. Agreed? Triangle ADC is congruent to triangle AEC B because of the side angle side theorem. And finally, now that I've shown my two triangles to be congruent to each other, now I can say that these two angles are congruent. Why is that? Well, if my two figures are congruent, their corresponding parts must be congruent. And that's because of the congruent figures implied corresponding parts are congruent theorem. CPC, wait, I wrote it wrong. CPCF theorem. There we go. Okay, done. All right, given XA equals YA and XC equals YC, we want to show again that angle XAC is congruent to angle YAC. I'd like you to pause the video and try it on your own. I've given you a grid, so I want to see if you can fill in the missing pieces. Go ahead and put me on pause. All right, now that you're back, what is the justification for this first one? Hopefully you wrote given. AC being congruent to itself, or sorry, the measures equaling itself. There we go. Measures equaling itself. Why do we know that? Because the reflexive property. And now, what can I say due to the side-side-side theorem? Hopefully, triangle AXC is congruent to triangle AYC due to the side-side-side theorem. Now I can talk about these individual angles. Angle XAC must be congruent to angle YAC because of what theorem? If my two figures are congruent, their corresponding parts must be congruent. So we're talking about this angle and this angle. Their corresponding parts must be congruent due to the CPCF theorem. Corresponding parts of congruent figures are congruent. All right. I'd like you to again put me on pause and see if you can fill in the portions on this proof. Okay, now that I'm back on, what is my first statement here? Yeah, I would start with BC is parallel to AD and BC equals AD. And that's already drawn in for me on my picture. Then I want to prove that these two triangles are congruent. So let's start with, what can we say due to the reflexive property? Hopefully the AC equals itself. And then why can I say that the measure of angle BCA must be congruent to the angle of DAC? Do you remember that theorem about parallel lines are transversal? If the parallel lines are cut by transversal, aren't those alternate interior angles? Yeah? Good. I'm going to say alternate interior angle theorem. If two lines are parallel, cut by transversal, your alternate interior angles must be equal, and vice versa, if your alternate interior angles are equal, your lines must be parallel. Just a reminder on this theorem. And then finally, why can I say that these two triangles are congruent? Because I have a side angle side theorem and in the correct order. Side angle side theorem. All right, we're going to do a few more of these tomorrow. But let's see. That looks a little, we'll do this one tomorrow. How about for tomorrow, why don't you try one where I've already written in a lot of steps? For tomorrow, why don't you try this one right here? Your given heptagon, ABCDEFG, is regular, meaning all your side lengths and angles are the same. And following the steps given on the proof, I'd like you to fill in those pieces and bring that in for me tomorrow. Tomorrow we'll spend a lot more time working on proofs with our congruence theorems. And I'll see you then.